Hello, I'm Lindsay Toth, an associate editor for JMPB, and I'm here to interview Kimberly Clevenger and Alex Montoy about their most recent article, Systematic Review of Accelerometer Responsiveness for Change for Measuring Physical Activity, Sedentary Behavior, or Sleep. Alex, can you briefly describe the systematic review for us?
I'd be happy to. Thank you, Lindsay. So I think readers of JMPB probably are familiar with the idea that we need to evaluate measurement tools before we can feel confident using them. We have to understand how accurately they measure whatever outcome or construct we're interested in measuring. Additionally, we have to know something about the reliability, whether that's between devices or over time. What gets looked at a lot less, at least in our field, is this idea of responsiveness, or we naturally change our behaviors over time, sometimes just seasonally, sometimes as we age, sometimes because of intervention to try to promote healthier behavior. But when we're using these measurement devices, we have to make sure that not only are they accurate enough to be meaningful, but also that they're responsive enough to be able to detect what are often small changes in behavior that people may exhibit. So just to give you an example, we often in the field would say that a measurement device that's within 10% of the real number is reasonably accurate, which for a metric like sedentary behavior, where people may sit 10 or more hours a day, we're saying really that has to be accurate within about an hour or so. Now, in our research, we found that most sedentary behavior interventions change sedentary behavior by maybe a half hour, give or take a little bit. And so if you have a measurement device that has potentially an hour of error, how confident are we really that it can detect a change like a half hour or 20 minutes? And so we wanted to undertake this review to see how responsive accelerometers and related measurement devices are and how much we know about them, because we know a lot more about accuracy and reliability.
Kim, in a nutshell, can you explain the results of your study?
Sure, Lindsay. So in our systematic review, we identified 26 articles that met our inclusion criteria. And I'm going to show you a heat map of our findings. So you can see that we've split up the different age groups, youth, adult, and older adults, the different wear locations, hip, thigh, and wrist, and then different outcomes that people might be evaluating the responsiveness of. So total physical activity, light physical activity, all the way up to sleep and sedentary time. And we've color coded these. So if you see a lot of red or orange, that means that there aren't a lot of studies that have investigated the responsiveness for that combination of age group, wear location, and outcome. And so overall, you're seeing a lot of red and orange in this figure because there's just not a lot of studies out there. In particular, there's not a lot of studies out there for thigh or wrist-worn accelerometers, not a lot of studies in youth, and we don't have a lot of studies that kind of evaluate the entire 24-hour movement behavior spectrum. So we really need more research, but we also need better research, because another thing that we found that's not shown in this figure is that most of the studies have not used kind of appropriate statistical approaches to evaluating responsiveness, and they also haven't included a criterion. So we have no way of knowing if a change actually occurred. So we don't know if the accelerometer should or should not have actually detected a change.
So this question is for both of you. What do you suspect is the primary application or use of your paper?
So we identified a few really common limitations of past studies on the responsiveness of accelerometers, like not including a criterion measure or using kind of inappropriate statistical approaches. So one of our main takeaways is that we need more studies on this, and we propose kind of two specific ways that we can go about this. One is to add a responsiveness component to existing kind of typical validation or reliability studies. And the second one is to build responsiveness into your pilot intervention work. So you can see more details about that in our paper, but I think that's two kind of direct applications of our findings.
And one thing I'll just add then is, while we haven't done a whole lot of responsiveness work as a physical activity measurement field, there are fields in which this responsiveness idea or tool is much more developed. And we cite some of those papers in our review as well, but we don't have to reinvent the wheel. We can go to other fields to understand how to do this well. And Kim's provided some really good ways in which our field can try to undertake this work in order to more fully understand our measurement tools.